All right. Can you now see the page that says compiler tool chains on the left and a terminal window on the right?
Yes.
Cool. Are they big enough to read?
They are fine for me.
Yeah.
Yes, yes.
All right,
Thank
good.
you.
Excellent. All right, then let's get started with compiler tool chains. So here we'll discuss what compiler tool chains are and very briefly why they're used. And hopefully by the end, you'll be able to figure out which compiler tool chains are installed on your own system, and you'll be able to load the compiler tool chain that you want. So most of the software at Swedish HPC centers is built around a what's called the Easy Build software framework. This is a system for deploying software quickly and easily. That's how we install stuff in a matter of minutes instead of hours or days. And under this framework, software is built around what are called tool chains. These tool chains are mutually compatible groups of compilers, mainly for C and Fortran, linear algebra libraries, MPI libraries, and other fundamental packages that are used internally by more familiar packages that you typically work with, like Python, R, GROMACS, VASP, those kinds of programs. They all have C and Fortran, at least C and Fortran compilers under the hood. And most of them have linear algebra libraries as well. Not all of them have MPI libraries, but anyway. If you want a metaphor for this, you can sort of think of the software packages you typically use like a car, like cars. And in that metaphor, then tool chains can be thought of like car platforms. So a lot of cars of similar size from several different brands will all source their specific engine components or power steering components, wheel axle, suspensions. They'll all source that stuff from the same manufacturer in the same sizes for similarly sized cars. So they're sort of like little, there's standardized parts that are functional under the hood. For instance, Python, that's actually one big wrapper around C. So you need at the very least a C compiler to make Python work. So that's why we use these things. So most HPC centers recommend using tool chains to build and compile software. And this is true whether you use Easy Build or not. And the reason is that software chains are sort of pre-assembled to make sure that the different components are compatible. And so that keeps your software, if you have a specified tool chain behind backing your software, it will be more consistent and reproducible. So there are a lot of different tool chains that are available at the different HPC centers, but usually they come in one of two flavors. There are the open source versions, and then there are the Intel versions. And there are a lot of different subdivisions of each, but they're all in these two main groups. And for each of these, you can use module spider and then the name of the tool chain to see which versions are available and what modules are required as prerequisites to load them, if any. I'm going to have to resize this window to see all the tabs. So at, for instance, Kebnekaise, there's at Kebnekaise and on Cosmos at HPC2N and LUNARC respectively, the available tool chains are more or less identical. You have the GCC for the C compilers only. You have FOSS, which is the sort of the whole enchilada for the for open source compiler or for an open source tool chain. So you get the GCC, you get the Open MPI, you get all these math and linear algebra libraries. And then occasionally you need something like GoMKL, which incorporates GCC and Open MPI, but then it uses the Intel math kernel library. And these other two you won't really encounter very often unless you know for sure that you don't need one or more of these like math libraries or Open MPI, things like that. And it's kind of similar with Intel. You have Intel compilers if you only need the compilers. The Intel toolchain that's just called Intel gives you everything that you might need. And then occasionally you'll see something like IIMPI, which gives you the compilers and the MPI, but none of the but not the math kernel libraries. At NSC and PDC are a little bit unusual in that they require prerequisites before you can even load a tool chain. On NSC, that tool the prerequisite is build tool - easy build and then some version numbers. And the selection of tool chains is a little bit more limited. At PDC, which is not shown here for lack of room, the prerequisite is the same PDC or PDC old that you need to load anything else. And at UPMAX, the selection is kind of similar to NSC, but there are no prerequisites required. There are also CUDA-based tool chains for GPU nodes. Usually, these are a little bit less common. And a lot of times, it's easier just to load one of these other tool chains first, and then just load a compatible CUDA if one is available. And you can use you can do model spider CUDA and to find a version and then see what GCC versions is compatible with, and then you can look for a compatible FOSS version or Intel version. So I know all of this is kind of overwhelming, especially for new users like you. So typically there's really only two good choices. If you're using open source software, you typically want to just use FOSS. That gives you everything you need. You don't necessarily need everything that's included with it, but it makes more stuff available if you're actually searching for stuff with ML-avail. And similarly, if you have software that's been built with Intel, you usually just want to go with an Intel toolchain. And if for some reason you have software that mixes the Intel math kernel library with other software that's all open source, then occasionally you need this GoMKL library. But anyway, these are the sort of three choices that that are good to remember. And if you want to check the available FOSS versions, you just use in most places you can just use module avail FOSS because there's no prerequisites with so over here in this terminal, I'm going to do just that with the on Cosmos to show you what's available. Oops. That was not what I was supposed to do. Email purge. It was email avail FOSS. There. So now you get a list of FOSS followed by a year and then a letter. What these numbers and letters are is that these are all releases. So the FOSS toolchain is updated about every 6 months. So if you see a year and an A, that means it was released in the first half of that year. If you see a B, that means it was released in the second half. And this little D here to the side, what that means is that if you type what I accidentally did before, mlfos, the version that gets loaded is the one that has this D next to it. That's the default. So you can see that was 2024.5, and there it is. Now on Tetralith, if I do ml avail FOSS, it's not found because this actually requires a prerequisite. So let's look at module spider FOSS. So now I need to select a particular version to look at the dependencies. So let's just do 2023B since that's already highlighted. And so now you can see is that you can choose one of these tools to prerequisites. I'm going to pick the older one for no particular reason. And now when I do ml avail FOSS, it shows two versions that are available to load. And if I don't give the version, then what gets loaded is the default version, which is usually the latest. So if I do ml, but I can do ml FOSS 2022A instead if that's what I would prefer to load. And now if I do ml, you can see everything that's loaded here. So this was the sticky module that's always loaded. This is the prerequisites, and then all the rest of the stuff is what was loaded with this toolchain. All right. And we've already gone through all of that. So I forgot to show, no, I did show that on Cosmos, when you load the default toolchain, this is everything that it loads. Or rather, everything except this software tree, which is always included. So what's nice about once you've loaded a toolchain, a whole lot of new modules become available. So if I do ml avail on Cosmos, now there's this really long list of things under different parts of the software directory tree. I'm not going to go through the entire list, but if I then do ml purge to get back to just this original software tree, and then I do ml avail, the list is quite a bit shorter. I mean, it's still quite long, but it's shorter than it would be if I had still kept the 2024.05 toolchain loaded. I already discussed defaults. Anyway, if you do note that if you switch toolchains, the module system will attempt to upgrade or downgrade any associated modules to match. So if one or more of the modules that were loaded for the previous choice of toolchain do not have a version that is installed that is compatible with the next toolchain that you've loaded, then the module system will raise an error and it won't change. And also, if there's a built-in system version of a package, one or more of the module, and then one or more modules provide alternative versions, the version that is loaded by the module takes precedence. That's good because the system version of a package is susceptible to change, and it's best to avoid it if you want your programming to be reproducible. Prime example of this is Python. So since nothing else is loaded, if I do Python -- version, you get Python 3.9.18, which is actually quite old compared to what is actually available with the with modules. So if I do module spider Python, You see it goes all the way up to 3.12.3. So you want modules to override system versions. Now, if you're compiling, this is the last section here. If you're compiling code with the toolchain, I've compiled these two tables of the appropriate toolchains and MPI libraries that based on the toolchain and the coding language. Or sorry, I've got these two tables of compilers by coding language and toolchain. So if you have serial code, all you need is the toolchain, or all you need is the compiler, and then so for a GCC, for open source software and a GCC toolchain, you have the GCC, G++, and G Fortran compilers. And for Intel toolchains, there are two versions. The first versions here that do not have the X, those will generally always work. But there's also there are also versions that end in X that are for these newer One API versions supported from 2023 onward. For some open source toolchains, they're like, particularly if you're using like older Fortran code that uses G Fortran or just plain C code that uses GCC, there may not be any real difference between how it compiles with a toolchain or how it compiles with the built-in compiler. The main differences are visible when you use MPI. So with MPI, there's also specific MPI compilers based on toolchains and languages. For C, it's MPI-CC. For C++, it's MPI-CXX, and for Fortran, it's MPI-Fort for OpenMPI. And if you're using an Intel toolchain, the names are pretty similar, except the I is usually doubled. The main exception is here with C++. It's CPC instead of CXX. It's also a little bit different what the running command that you use inside of your batch script or at the command line. For OpenMPI jobs, not using threads, we use MPI run and then specify the option -- bind to space core. For Intel-based MPI scripts, the script is usually run with srun with some arguments. So here is a template that you can use for a script that uses OpenMPI. And Brigitte will go into modules using batch scripts a little bit more later on in the course.